Okay, hi Zach, welcome to lesson 104. Today's lesson starts on page 439 of your book, and we are going to go over abstract rational equations. So it's kind of the same stuff that we were doing yesterday, I guess, or whenever you did the previous lesson. But instead of integers, there's going to be a lot of other abstract numbers, okay? So you already know how to do these. Basically, well, let's look at this first. Wait a minute, isn't anyone here a real sheep? Look at these guys. They were dressing up as sheep to try and be a wolf in sheep's clothing so they could trick a sheep, but it looks like none of these sheep are real. They went to a lot of effort to get those costumes though, huh? Alrighty. Okay, so just as a quick reminder, as a note to self, they start out with this, that when you see a problem like this and you see variables in the denominator like this, you know you're dealing with a rational equation. The first thing to do is say the things that x cannot be. So the denominator can't be 0 because you can't divide by 0. So in this example, x cannot be 0, and x, because of this, cannot be 2, because then you'd have 2 minus 2 and you'd have a 0 for the denominator. Okay, now they say from now on, you can just basically assume that you're not going to divide by 0, and you can just get rid of these types of notations in the problem sets and just assume that we're never going to divide by 0, because of course you know what happens when you divide by 0. Bad things, right? Okay, so let's start with example 104.1, and this is what they mean by an abstract rational equation. There are no numbers in this. This is a math problem with no numbers, but easy peasy, we can still do it. I'm going to move those minions out of the way because they're kind of distracting me a little bit. Okay, so the way to do it is the way to do the same problems if there were numbers. The first thing, and they kind of already put it in the problem, they said x and m cannot be 0. Okay, so now they said they're just going to assume that that's part of the problem. You don't have to include it in your problem set. So whatever. Okay, that's done. Now, the first thing that we do is find the LCM. The LCM in this example is going to be what? It's going to be xm. And then we do the same thing as we would with numbers. We multiply every expression by xm there, and even the c by xm. And so that way we get rid of those denominators, okay? So let's do that. All right, so this x is going to cancel this x. This m is going to cancel this m. So if I write the whole thing again, I'm going to just get rid of this so I have the room to do it. The first one is going to be m times 1, so it's just m. Then it's going to be plus, those m's canceled out, so it's going to be b in x, or xb, it doesn't matter, whatever, equals c. Since that's not a 0, we're going to do c times x times m. Okay, so that's what we boiled it down to. That leaves us with this equation. And now what we do is they want us to solve, what do they want us to solve for? They want us to solve for m. Did they say that in the problem? Let's see. Yeah, it said find m. So that's part of the problem. Find m. So basically what they want us to do when we get to this point is to solve it so that you've isolated m. Okay? So how do we do that? Just like if there were numbers. Let's get all the m's on one side of the equation. Okay, so now we have m minus m, that's just going to be 0, plus xb equals cxm minus m. Okay, now I can just get rid of that 0 plus because that's redundant. Okay, so now we have xb equals cxm minus m. So now what can we do? Well, we can factor out that m. So we'll have xb, whoops, let me get it different. Okay, xb is equal to m times, so we're just factoring this out. cx minus 1, right? Because if we multiply this guy out, we get this guy, right? So does that make sense? Okay, now we have to isolate the m on one side of the equation. So it's going to be divide this by cx minus 1, divide this by cx minus 1, and then you're left with just the m. M is equal to xb over cx minus 1. I could write it neater, but that's what it is. That's the answer. Okay, so now that's how we solve an abstract rational equation. So let's go to example 104.2. I know, you'd rather be on this beautiful beach right there, huh? That looks really beautiful. It doesn't look real. Maybe it's just a fake picture. 104.2 is this problem, and they want us to find b. And if you were stupid, you'd be like, there it is. That's the answer. No, but you're not stupid because you have to go through all the steps. They also tell you that b and d is not equal to 0. I didn't write that down, but there it is. Okay, so as the first step, we multiply by the LCM. The LCM is going to be what? It's going to be b times d. So we're going to multiply everything by b times d. I'll just put it there. Okay, so this b cancels and this d cancels. That's kind of confusing. So we have da plus bc equals xbd. Yikes. Okay, that's a lot of letters. Now, what do we have to do? We have to use the additive property of equality to put all the terms that have a b in it on one side of the equation. All the terms that have b have to be on one side of the equation, which is this and this. Okay. So it's going to be subtract bc, dA equals, I'm going to put xbd minus bc. Okay, now I'm going to factor out this b. Let me change colors. dA is equal to b xd minus c. Okay, got it. Now what do we have to do? As the last step, we have to divide both sides of the equation by this guy. That way we have isolated the b. Okay, so we're going to isolate the b. So we're going to divide this by xd minus c, and we're going to divide this by xd minus c. When you do that, this cancels out with this, and because of that, you have isolated the b. So b is equal to that. Easy peasy, right? Okay, let's do example 104.3. I know, just go to your happy place, and then this will soon be over. Okay, so in this example, they are telling us find x. So we have to isolate this guy. All right, how are we going to do that? These are kind of fun, I think. This is kind of like solving a Rubik's Cube. Super satisfying. How do we isolate that x? First, let's eliminate all the denominators by multiplying by the LCM. So the LCM is going to be bx. Even though they're not on the same side of the equation, it's okay. We can multiply everything by bx. That's a multiply, not over. Let me make that clear that this is that. And then multiply this guy by bx. Okay, so what cancels out? So this b cancels this b, this x cancels this x, right? So now let's write it again. So it's going to be xa for that first term minus bxc equals, that cancels that x, db. Okay, now we're supposed to be isolating the x, right? So let's factor out this x, and this x. So if we factor out the x, we have a minus bc equals db. Okay, divide everything by, it should be the whole thing. Divide everything by a minus bc. Divide this by a minus bc. And now you have isolated the x because that cancels that. Sweet. Sweet. That's the answer. Super fun. They wrote it different, right? They wrote BD right here. And as you know, that doesn't matter because multiplicative property, is that the property that says the order doesn't matter? Well, it doesn't matter in that situation. All right. One more time to put yourself in your happy place because this is the last example, and here's a beautiful happy place that you can imagine. On this one, they want us to find x. Find x. Okay. There it is. Yeah, wise guy. We can't do that. All right, we have a rational expression. We need to find the LCM, and we also know that x and n cannot be 0, right? That's a given. Okay, so let's find the LCM. We're going to multiply everything by x times n just to get rid of those nasty denominators. I'm going to move that up. Okay, and this is going to be xn. This is going to be xn. Okay, what cancels? This cancels this x. This cancels this n. Now let's rewrite the whole problem. We have NA minus xny plus mxn. Oh, nope, that n cancels. So just mx equals kxn. Okay, that's a lot of letters there. All right, so now what do? We have to, what are we solving for again? We're solving for x. So anything with an x on it, we got to get it on one side of the equation. And anything that doesn't have an x, we got to get it on the other side of the equation. So we are going to, let's see, let's put all the x's to the right. So we're going to add x and y here. We're going to subtract mx here. And we have to do the same thing to both sides. So we're going to add x and y, and we're going to subtract mx. I'm running out of room. That's all right. Okay, let's write it again. So we have NA left on this side of the equation, and then we have equals x. Okay, let's start with this one because this is how they wrote it. X and k. Now that's the same as kxn, so it's okay that that is the same. And then they have plus, whoops, plus x and y. Oh, minus, that should be minus. Minus mx. Okay, because this cancels here, this cancels here. And then you just basically add all of this stuff together on the other side. Okay? Easy peasy. Okay, now let's see, let's factor out that x. So if we factor out this, all of these x's on this side, so we're going to have NA equals, let me do a different color because I can't see it. This is the next step. NA equals, let's factor out the x, NK plus NY minus M. Okay, sweet. Now we just have to basically divide by this whole expression. It's going to cancel on this side, so we're going to bring it over here. So I can do that in my head now. I got it. I can do it in my head. So I'm just going to bring this over here, and then I'm going to bring this here, and then I'm just going to draw a line. Did you get how I did that? Yeah. I did it in my head. You probably did it in your head and you were done like 5 minutes ago. Oh well, go to your happy place. All right, love you, Zach. Have a great day. Bye.